So today we'll be talking about Spark, and it will be all related to the interview types, interview questions, and whatever the type of the questions that are asked in the interviews, that we'll be discussing with a proper example, with the proper things and a proper explanation. I have taken my pen tablet and वो सारी चीज़ें I'll be telling you with a proper example and my experience. I'll be simplifying everything in a very easy and simple detail. And if you have an interview like about 4 years, like for 4 years, 5 years role also, then also you can just crack it. So that also you can do. And if you have an interview like after 10 days also, then also you can do it. So basically then also, and if you have an interview tomorrow also, then also you can do it if you found this video. So let's start. And if you like this particular video, definitely drop a comment and just appreciate me. Definitely it will give me a full amount of motivation. And if you have not seen my sequel video, definitely go on the sequel part and see that also after this particular video, because that is also related to the interview part. And we have talked about from the basics to the advanced things, and also the theoretical and also the optimization part. So that will definitely give you a very great insight. So let's start without delaying much. So very first thing that is so as you can see on the screen, यहाँ पे देख पा रहे हो, the very first thing that is major Spark question, the major Spark question that can be asked, and what is Apache things that we'll be talking in detail. So basically this is Apache Spark and why it is used, what it is, that also we are going to discuss. We are going to talk about the key concept, we are talking about the practical question, we are talking about the interview tips also. So these all things are included in this particular video, and definitely it will be very insightful. If you don't know also about anything about Spark, then also you will give it in that insight. So very first thing, that is, let's start with a very simple thing, that is what is Spark. What is Apache Spark? What is Apache Spark? Apache Spark करता क्या है भाई, इतना नाम क्यों है इसका, हर जगह इसका नाम सुन रहा हूँ. Whenever I am going for a data engineer interview or a data domain interview, I am listening about this particular concept. So basically Spark is a very powerful framework, and it is widely used for data processing. Whenever we are doing a big data processing, we are doing the big data processing in a distributed manner. So basically that is a very powerful framework, and it uses the distributed system. And being a familiar with both theoretical and practical questions is crucial for any data engineering role. If you are going for any data engineering, definitely it will give you. And in this particular video, we'll walk through about all the things and all the things by the end of this video. So the next part is, what is Apache Spark? That is Apache Spark, what is it? So basically whenever we are talking about Apache Spark is open source distributed data processing framework. As I have told you, it is an open source data processing framework, open source distributed data processing framework. It is a very important term, that is distributed data processing framework, and designed to handle a large scale data in real time. That is, you can if you want to process the data in real time in very large scale also, that also can be done in a very distributed manner via the Apache Spark. And it provides a fast and general purpose engine for large scale data processing, supporting in memory computation. But that is, suppose there is a traditional concept in Hadoop, that is of MapReduce. Basically it is a very advanced version of it. That is what it does. It does a map function, then it does a reduce. That means there is a disk, it will write to a disk, it will do the processing, it will do the computation, then again read from the disk and give it. But in Spark we are doing, basically it is very faster, because the very first thing we are doing in memory processing. The very important thing, that is the most important part, if I highlight that, that is supporting in memory computation. This is the most important point, that is it does in memory computation. And mostly you will get this question, that is compare MapReduce with Apache Spark, or what is the advantages of Apache Spark, why MapReduce is not used this much, and why Apache Spark is better. These kind of questions can be there. So these kind of things can be fetched from here. Next thing is, which makes it very faster from the traditional MapReduce, and it is used in variety of the tasks, including ETL, while we are doing the extraction, transformation, loading also. When we are using machine learning, when we are doing a real-time data streaming, Apache Spark can be used. So that is a very multi-purpose framework that can be used, and it helps you to process the large scale data sets very easily in memory and very fast way. So basically there are the main features. If we go for the main features, the first one was the very important thing, that's in memory processing, that enhances the speed. So basically it will enhance the, then lazy evaluation, that also increases the efficiency. I'll explain you, no worries, what is lazy evaluation, what are the in memory processing, these kind of things. Then there is a fault tolerance. That means if there is a like in memory processing happening, there is a large data set, so there can be chances that in between there is a failure. So there is a concept of fault tolerance also, and there is a data lineage by which you can track where the data got failed, from where you need to resume, and it resumes from there. Okay, that is also a very good concept. Then support batch streaming and interactive workloads. That means if you have if you know that 10 GB of data will be coming every like every day at 7 p.m. I can just reload that, like load it or transform it or do any processing on it. So that is called as batch processing. In live, if you want to do in real time, that is the data is coming in and you want to process it right away, so it is called as streaming. Interactive workloads are there. So basically these kind of concepts are very, very important. Next thing, what is RDD? Whenever we are talking about a Spark, whenever we are talking Apache Spark, about PySpark, about distributed computing, RDD will come, that is resilient data sets. What is the resilient data set? Basically resilient data set is a fundamental data structure in Spark. That is how the data is getting stored. It is stored in the format, you might have heard about arrays, you might have heard about lists. So basically it is a fundamental data structure that can be used, that cannot be used, that is not the right word, that is used to store the data, or it is a kind of a fundamental data structure that is used in Spark. It is a distributed collection of objects that can give you process in parallel across the cluster. RDDs are immutable. That means if you do any changes in the data, the new RDD is created. You cannot update it. You cannot, as in list what we do, you just update it. So basically here you cannot just update it. You have to create a new RDD. So basically that is created. It is immutable and it is fault tolerant. For example, if a node fails, RDD can automatically recover lost data thanks to the lineage information. As you are having the lineage information, that means if there is a checkpointing here and if a large data set is processing, if it fails here, you know that from where to resume it. From this you have to resume it, or from this, so that no data is getting lost or data integrity is maintained. So basically that is important. Next is, for example, if you want to create an RDD, in PySpark, by parallelizing, you can use this particular function, that is you can parallelize sc.parallelize, and you can just create an RDD. It will be an RDD. You can apply the transformation actions on it, and it will be a kind of a data frame that you can just use, and it will be kind of a data structure that can be used, and you can do some practical aspects, and you can understand more about RDD. That you can do on Jupyter also. So basically that is the thing. Next thing is, if we talk about the architecture, that is very, very important and the most asked question, that is about the Apache architecture, like how Apache architecture is used, and what are the things that can be done in Apache architecture, how it is processing the data. These kind of question can be asked from the Apache architecture only. So basically it uses a master slave architecture. With it has two types of things, that is a driver and an executor, or also called as master and slave. The slave is the executor and the driver is the master, where the master says the driver program runs the master node and coordinates all the activities. That is, master node will do all the will coordinate all the activities, and it will distribute the data as per the requirements. And while the executor will run on the worker nodes, and it will execute the task assigned to them. Whether suppose a task is there, it will be divided into different parts, and it will be assigned via the master nodes to different worker nodes, and the worker nodes will execute that particular task in different time, and it will do the proper task. Like it is responsible, driver node is responsible to, executor node is responsible to execute the task, driver node is responsible to distribute the task. That is the thing. The cluster manager, there is a cluster manager which is called as YARN, yet another resource negotiable, that is a full form of it. And there can be Mesos also, and or a standalone. These kind of resource like what we say, the resource managers can be there, that can give you a proper resource allocation. And the driver creates a directed acyclic graph, that is DAG, and submits the cluster manager, then splits the state into executors. That means if you want to see a practical example how it works, so basically this is a very good diagram that I found on the internet. Basically, whenever a data is coming in, basically the driver node that will start the Spark context, from where the Spark, whenever the Spark job will run, it will start with the Spark context from the driver program. It is inside the driver program, it starts from here, and from here it will go to the YARN, that is it, resource manager, that is a resource manager, that will say कि हाँ भाई कितना resources किसको देने हैं, कैसे काम चलेगा. तो basically that it does. So basically the this thing will go here, and it will distribute the task accordingly. See here, this is one executor, this is second, this is third. So like the data is distributed very properly, and the data is distributed like 1 2 3 4, and every executor has the task. Every executor has their HDFS, that is Hadoop distributed file system, where the data is getting stored, and there is a cache memory where they can store the data. If there is a proper every time it is getting evaluated the same thing, it can be cached there, so that the performance is improved. So these kind of things can be asked in interviews. And definitely this architecture is very, very important. If you want a dedicated video on it, and so that I can explain it much better, definitely you can ask it in the comments. I will definitely make a video of 5 to 6 minutes that explaining the same thing again. Okay, then what is the role of a DAG, that is directed acyclic graph in Spark? So basically like a Spark job is basically formed in whenever a job is created, a workflow is created, basically it is formed in a form of a DAG, and it is a set of processing steps where each node represents a computation and the edges represent the dependencies. That means each node, this is the represents the computation. That is, here some computation will be done, here some computation is will done, but here that means it is a directed acyclic graph. That means when a resource or a task is running, after this has to run, after this has to run, there is a dependency, one-on-one dependency is there, so it is showing that dependency. That means the edges shows the dependencies and the nodes represent the computation, how the data is getting computed. And DAGs plays very important role in the fault tolerance. Suppose this is one of the tasks, suppose I create this task and the data is flowing in this direction. So basically if it fails here, I know where it failed and from where to resume it. So in fault tolerance it is used very much. So basically that is one of the things. Then failures and optimize the execution plans. It also gives the recover plan also. It is very important. So here also you can create a map, and internally you can create a DAG and you can recompute it and you can practice it basically, and you can also perform the transformation on it. So just to get a better understanding on that, so that you can do. Next thing is transformation and actions. Next thing, what is the difference between a transformation and an action in Spark? So basically there's a concept of a lazy evaluation. So basically in that, when you will read about lazy evaluation, there is then the reference of these two topics will come, that is a transformation and an action. What's the difference between these two? What is a transformation, what is an action? So I'll explain you in a very simple thing. That is, there is a transformations are lazy operations. That is, suppose you do a map, a filter on this, so basically you are not printing it. So what will happen, it will not apply those things till you have invoked that particular show display. Till that, if you print the data, then only that particular command will run. It will do a map, it will do a filter on that particular time. So it improves the efficiency and also it improves the performance of that particular job. So basically what will happen, I'll explain you. Transformations are lazy operations that creates a new RDD from the existing ones. They are not executed immediately, मतलब वो तुरंत नहीं चलेंगे. It will only execute when the action is called. That is, examples of the transformations are map, filter, group by, these kind of things, because we are not printing it. Till you have not printed or if you have not done any action on it, so till then you will not get any result there. So basically what you can do, the action on the other hand triggers the execution and it will run the Spark job, and the action can be collect, it can be count, it can be reduce, it can be display, it can be print, anything, it can be anything. Okay, so whatever the action, if it prints or it displays something, that means you are doing an action. That means at that time only the Spark job will run. That is the meaning of a lazy evaluation. Okay, next thing is transformation and actions. So what are the narrow and wide transformation? So basically narrow and wide transformation are usually happens when a distributed data is there, because a large amount of data is there. And if we talk about the Spark architecture, so basically the data is getting transferred from the worker node to different worker nodes or executor, or from the driver to this one. So different kind of data latency can be there and different kind of things will be there. And data transformation, narrow transformation and wide transformation means a narrow transformation are those which partition contributes to only one of the output partition. That means map, filter. Wide transformation like group by and join, it involves data shuffling, because if you do a group by on that, the full result will be changed, it will be shuffled, like the data will be shuffled, the executors, the result will be shuffled. So there it happens. And if you are doing across the partition, the shuffling can happen. And basically many times if you are doing a Spark optimization, we avoid wide transformations, so that can be avoided to improve the efficiency, and we use more of the narrow transformation, so that the efficiency can be improved or it can be better. So basically what is a SQL, Spark SQL, and how does it work? So if we talk about the Spark SQL, it is a module in Spark that allows you to work with distributed structured using the SQL queries. It is particularly used for querying the data from various sources such as JSON, Hive, Parquet, JDBC. So basically it is not very sure that if you're talking about distributed system, so it will be in the form of a database only. It can be a Parquet file, it can be a Hive file, it can be a JSON, it can be a JDBC file. So basically you have to do Spark SQL is used. So basically it is a SQL type of syntax on which you can by which you can run the SQL type of syntax on the JSON files, on the JDBC files, on the Parquet files, so that the data can be fetched. So basically it integrates with the Spark core, so it is very beneficial for the Spark distributed nature, and you can just fetch the results from there. Next is Spark SQL and data frames. What is a data frame? So basically these are the very fundamental concepts, that is it in a distributed system. Data frames are the collection of the data organized into the name column. Basically you can assume as data frames as a database where in a row and column the data is stored. That means, but it is a distributed system. Okay, so that's why it is very different from the relational database. It can be conceptually equivalent to a relational database, but not theoretically, basically. Okay, then data frames provide optimized execution plans and are more sufficient. RDDs are for many operations. These provide the support for various data sources and for formats. So these kind of things can be used. And in example, if you want to create a database, you can create from a CSV file, you can create from a table, you can create from a data frame, you can create from a different join conditions, from a file, from a JSON file, from a Hive file, any type of file, any type of Parquet file. You can just create a spark.read function is there, read, and you can read the CSV. You can give header is equal to true and infer schema equal to true. That means you are giving that the first line of my file of the CSV is my header. That means it contains the column number, column names, and these kind of things. And next thing is infer the schema. That means if it is having a string type of value, just give the schema as a string. So that means it will just infer the schema. It will create a default schema. Then performance and optimization, these kind of questions can be asked, and it can be very much useful. That is, you can optimize, how you can optimize the Spark jobs. There are various ways to optimize the Spark job basically, and it can be used basically. How you can optimize it, the first one is partitioning. Properly partitioning your data and distribute the workflow very evenly. That is, you are distributing the data very evenly, you are distributing the things very evenly, so that the performance is increased, so that data is not very skewed. Next thing is caching. You are storing the intermediate data in the memory and using the cache and persistent. Suppose you are having the intermediate data, means that there are several steps. Now in the several steps there can be intermediate layers between them. So in every step you can just store, you can cache that particular data in memory, so that the evaluation is very faster, and whenever you are doing a query or whenever you are running a job, so it will very faster, you can just give the answers of it. So it works like that. Next thing is broadcast join. So basically the broadcast variables or a broadcast join, how it works, you can avoid the data shuffles, and if there is a small table, there is a large table. So basically a broadcast variables, what it does, you just distribute if there are many executors here and there is a driver here. Okay, so just distribute that particular variable to all the executors, so that they will have their copy. उनके पास सारे के पास कॉपी रहेगा, और वो ऐसे परेशान नहीं होगा कि हाँ भाई कहाँ से क्या चीज करना है, कहाँ पे क्या चीज डिस्ट्रीब्यूट करना है, ऐसे टेंशन नहीं लेंगे. उनके पास सारा बस यही है. डेटा लेटेंसी का थोड़ा इश्यूज हो सकता है. दैट्स व्हाई देयर इज अ लिमिट. यू कैन नॉट broadcast a proper variable that is having a very huge data, that you cannot do. So that is one of the limitation. Then is serialization. Then is using faster serialization method like cryo and these kind of things, and you can also cache like this, like caching a data frame. So basically that you can be done. Then Spark streaming is there. There is a concept of Spark streaming. That means a real-time processing if you want to do. There is Spark also allows that, and it says you can do a Spark streaming. It is a real-time data processing tool engine that processes a continuous streaming data. That is, data is coming in a flow, and you are processing it and giving it right away, on printing it right away, or storing it, displaying it somewhere right away. That means you are processing it right away. And it divides the small batches and processes them into as RDDs. You can also use dstream for the real-time computation. You can also do the restream. That means the Spark, there is a Spark streaming. Basically, there can be used these kind of technologies, and you can do a Spark streaming. It can be Kafka, it can be Flume, it can be HDFC, it can be S3. On the S3 you can do a Spark streaming. Kinesis you can use from Twitter, from data, like you are fetching the data from different sources, where the data is getting like cricket data. क्या होता है कि हाँ हर बॉल पे वो चेंज होता है. तो बेसिकली हम लोग क्या करते हैं कि हाँ डेटा प्रोसेसिंग, लाइक रियल टाइम डेटा है, वो हर सेकंड पे, हर मिनट पे, हर आवर पे चेंज हो रहा है बेसिकली. तो दैट कैन बी अज्यूम्ड एज अ रॉ डेटा. देन Spark streaming can be used, and you can store store this on HDFC, on database, on dashboards, and you can print it. Basically, how this is how it works. Then there can be questions on the handling the failures in Spark. So basically, there can be questions on how does the Spark handles a failure. So basically, whenever a failure is there's a fault tolerant concept of frame. The Spark Apache first Spark has the fault tolerant, and it is meaning that it recovers the lost data and resume the executions in event of the node failures. It achieves this through RDD lineage, which track the sequence of the transformation and lost the data. मतलब जो भी IDDs lost हो रही, जो भी IDDs वहाँ fail हो रही हैं, you are having that particular plan, you are having that particular track, you are having a proper data for it, and you can just resume it from there. That is very easy. Like अब हमारा जो fault tolerant method है, fault tolerant engine है, वो बहुत अच्छे से काम कर रहा है वहाँ पे. तो वो है. उसके बाद फिर इंटरव्यू से सिनेरियो बेस्ड क्वेश्चन बहुत ज्यादा पूछे जा सकते हैं ऑन द स्पार्क. दैट कैन बी डन. दैट इज हाउ वी डू ट्रबल शूट. देयर इज अ लॉन्ग रनिंग जॉब. बहुत ज्यादा टाइम ले रही है. इट इज लेकिन लाइक 3 hours टू रन द डेटा, एंड आइडियली इट शुड टेक ओनली 1 hour और 30 minutes. ठीक है, तो उसको हम लोग कैसे उसका परफॉर्मेंस इंक्रीज कर सकते हैं, उसका रन टाइम डिक्रीज कर सकते हैं टू 30 minutes. तो वो सारी चीजें आपसे पूछी जा सकती है ऑन अ वेरी सिनेरियो बेस्ड, लाइक सिनेरियो काइंड ऑफ थिंग्स. तो ऐसा भी हो सकता है. एंड यहाँ पे जाते हैं, आई विल शो यू अगेन. ओके, तो ऐसा हो सकता है. एंड तो आप क्या कर सकते हो इन दैट केस, यू कैन एनालाइज, बेसिकली एनालाइज आप कर सकते हो. एंड जस्ट टर्न ऑन द पेन. ओके, you will start analyzing the job execution stages. आपको अलग अलग स्टेज है, बिकॉज स्पार्क ऑल्सो गिव्स अ यूआई. आप इस स्पार्क यूआई में देख सकते हो कहाँ पे कौन सा जॉब कितना टाइम ले रहा है, कहाँ से हमें सही करने की जरूरत है, ये सारी चीजें. यू कैन चेक द स्क्यूड डेटा. इफ देयर इज अ स्क्यूड डेटा, अ पर्टिकुलर पार्टीशन इज टेकिंग वेरी लॉन्ग टाइम. अगर आपने लॉगिन सही से अप्लाई किया, आपको पता रहेगा कौन सा पार्टीशन बहुत ज्यादा टाइम ले रहा है. तो वहां से आप चेक कर सकते हो. डेटा स्क्यूनेस अगर हो रहा है तो उसको इंप्रूव कर लो. उसके बाद रिव्यूइंग द मेमोरी सेटिंग्स. अगर मान लो मेमोरी में कुछ कंप्यूट में हमारे प्रॉब्लम है, कुछ जो हमने कंप्यूट क्रिएट किया है वो छोटा है, लाइक उसको हम उसके लाइक उसके और जीबीज बढ़ा सकते हैं, उसका और साइज बढ़ा सकते हैं ताकि हमारा कंप्यूटेशन और फास्टर हो जाए. उसके बाद कॉमन ऑप्टिमाइजेशन इंक्लूड्स एडजस्टिंग द पार्टीशन साइज, मिनिमाइजिंग द सफल्स एंड इंक्रीजिंग द पैरेललिज्म. दिस काइंड ऑफ कंसेप्ट कैन बी यूज्ड. नेक्स्ट इज हाउ वुड यू डू इफ द स्पार्क जॉब इज रनिंग आउट ऑफ मेमोरी. अगर आउट ऑफ मेमोरी हो गई तो भाई, तो आप क्या कर सकते हो. देयर आर ओनली वन स्टेप, दैट इज serialization हम कर सकते हैं. नेक्स्ट इज रिड्यूस कर सकते हैं पार्टीशनिंग को, या हम लोग मिनिमाइज कर सकते हैं जो कंप्यूटेशन का पावर है उसका कंजम्पशन हम लोग कम कर सकते हैं. तो वो चीज है. अब यही सारी चीजें हैं. एंड अगर आपको कोई और डाउट्स है तो कमेंट में पूछ सकते हो. अदर देन दैट, अगर आपको पर्सनलाइज्ड गाइडेंस को चाहिए तो आप मेरे को टॉपमेट में कनेक्ट हो सकते हो. द लिंक इज इन द डिस्क्रिप्शन. सोशल मीडिया का वहीं पे आपको लिंक ट्री पे ही सारे मेरे सोशल मीडिया के लिंक्स मिल जाएंगे. मेरे को इंस्टाग्राम पे कनेक्ट कर सकते हो. देयर आई पोस्ट कंटेंट रिलेटेड टू लाइक क्रिस्प में बहुत डेटा डोमेन से रिलेटेड सारे कंटेंट, और कोई कोर्सेज वगैरह रहते हैं डेटा डोमेन से रिलेटेड, वो सारी चीजें मैं वहां पे दे रहा होता हूँ. एंड अपना पर्सनल गाइडेंस भी दे रहा होता हूँ. डेफिनेटली आपको हेल्प होगी. मैं लाइव भी आता रहता हूँ वहाँ पे चैनल भी हमारा, जहाँ पे हम लोग ब्रॉडकास्ट चैनल पे भी बातचीत करते रहे, लाइव करते रहते हैं. तो वहाँ पे आपको काफी ज्यादा हेल्प हो रही होगी, तो वो आप जरूर फॉलो कर सकते हो. अदर देन दैट, हमारा एक ब्लॉग चैनल है जहाँ पे हम लोग मस्त मस्त वीडियोस, घूमने फिरने से रिलेटेड हमारी पर्सनल लाइफ हम लोग शेयर कर रहे होते हैं. लाइफ में क्या चल रहा है, कैसी चीजें चल रही है, कैसा मैं सेटल हो रहा हूँ, क्या कहाँ पे जा रहा हूँ, कहाँ नहीं जा रहा हूँ, वो सारी चीजें मैं वहाँ पे शेयर करता हूँ. अदर देन दैट, ये चैनल तो है ही हमारा जहाँ पे हम लोग रेगुलर बेसिस पे कंटेंट, टेक्निकल कंटेंट डालते रहते हैं. डेफिनेटली इसको फॉलो कर सकते हो. मिलते हैं आपको नेक्स्ट वीडियो में. जय हिंद, वंदे मातरम. बाय बाय. वीडियो अच्छी लगी हो लाइक करें, कमेंट जरूर छोड़ के जाना, एंड अपने दोस्तों को शेयर कर दो अभी के अभी. बाय बाय.